going to process, and this is a SQL training session. Now I'm going to use some platform, so I'm going to start with installation. So you just come here to your browser and just write XAMPP, XAMPP, download. It's going to take you to Apache Friends, download XAMPP, and you'll find this is easier to download than Workbench because you have, okay, you can download the one with the latest version of PHP. Just click on download, and your download should start immediately. Yes, I think I downloaded this yesterday. You can still download it again. Save file, okay. Yeah, this will be the second one of those. So in my downloads, I have XAMPP, and I mean this XAMPP, the one for yesterday. This one is not done installing. And then run as administrator. Run. Yes. Tsunami. Okay. Then we'll come to XAMPP setup next. You want to install all of them. Next. XAMPP. Now, this should work in your computer. It won't work in mine because I already have that folder here. You see, XAMPP installs itself as a server. So it won't work because obviously I already have this file here. Yeah, it won't work. But basically, if you click next, and if I delete that, I'm going to delete my files. So for now, I'm going to change to install inside XAMPP. And then I'm going to uninstall it later. So XAMPP, next. Okay, create a very empty folder. New folder. So select folder. Next. Next. I've said this is just for me. Otherwise, your default location should work. Yes. Next. English. Next. This one is learning more online. Okay, allow me to just let me see whether it asks for anything else. So it should unpack up to the end. You're going to find this one is actually easier to install than Markbench by far. Okay. Now, as we do that, let's go through the notes. You're going to get this PDF. So, what is SQL? SQL is a language to operate databases. It's basically the language in which a database will understand, so you have to learn it for you to operate it. Now, it includes database creation, deletion, fetching rows, modifying rows, etc. Then SQL is an ANSI, that is an American National Standards Institute standard language, but there are many versions of the SQL language. Now, SQL is structured query language, which is a computer language. Okay, as I continue, you have to say allow access in Apache. Is a structured query language for storing, manipulating, and retrieving data stored in a relational database. Yeah, SQL is the standard language for relational database systems. All the relational database management system like MySQL, MS Access, Oracle, Sybase, Informix, Postgres, and SQL Server use SQL as their standard database language. So you can note that MySQL is a relational database management system. MySQL, MySQLi. Okay, I can start the control panel now. Okay, then they are using different dialects, but they use something like, for example, when you say English, there is American English, there is the UK English, there is Kenyan English, there is Ugandan English, South African English. The same with SQL. When you're using MySQL, you use a certain dialect. When you're using PLSQL, you're using a different. It's still SQL, just some different changes, very minute. Now, why is SQL so popular? It allows us to access data in relational database systems. It allows users to describe the data. It all allows users to define the data in a database and manipulate that data. Then it allows to embed within other programs using SQL nodes, libraries, and precompilers. Then allows users to create and drop databases and tables, then allows users to create views, stored procedure functions in a database, and then allows users to set permissions on tables, procedures, and views. Now, the history of SQL, I'm going to skip that, and because it has just installed, you see here, you can click start, and it's going to ask you that, and just say allow access. And for now, I'm going to use the shell for now. You have to learn how to code all this from scratch. So for me to start my SQL, I'm just going to write my SQL -u or -u root -p. Yeah, it has to be in small letters. Yeah, enter password, don't enter anything, just leave it blank and press enter. Before, yeah, and let's just leave it there for some moments. Now, when you're executing an SQL command for any relational database system, the system determines the best way to carry out your request, and the SQL engine figures out to interpret the task. Now, there are various components included in this process. These components are: one, query dispatcher, optimization engines, classic query engines, SQL query engine, etc. Now, a classic query engine handles all the non-SQL queries, but an SQL query engine won't handle logical files. Yes. Following a simple diagram showing the SQL architecture. When you write an SQL query, then you query language processor. Then you've got a parser and an optimizer. Then you get this one is sent to the DBMS engine, where you have also the file manager and the transaction manager acts upon it. Then you've got the physical database. So as you can see here, the physical database is going to be connected to via a DBMS engine. Now, SQL commands. The standard SQL commands to interact with a relational database are create, select, insert, update, delete, and drop. These commands can be classified into the following groups based on their nature. 1. Data definition language, that is DDL. The command is create. It creates a new table, a view of a table, or other object in the database. So you can create database, you can create a table, you can create anything you want, literally. Then you've got alter. It modifies an existing database such as a table. Then drop defines deletes an entire table, a view of a table, or any other objects in the database. Then DML, that is data manipulating language. Select, the command select retrieves certain records from one or more tables. Insert creates a record, update modifies records, and delete deletes records. You're going to note here the language is a bit different because it's for data manipulating language. So here we're dealing mostly with records. Then DCL command, this data control language. This is when you want to create a user, for example, admin. You can grant a privilege to a user, so you can revoke those privileges from a user for a user. Now, what is a RDBMS concept? Now, RDBMS stands for Relational Database Management System, and RDBMS is a basis for SQL and for all other modern database systems like MS SQL Server. MS SQL Server is the server for Microsoft by default, IBM, DB2, Oracle, MySQL, and Microsoft Access. A relational database management system is a database management system, that's a DBMS, that is based on the relational model as introduced by EF Code. Now, what is a table? A table is, now the data in an RDBMS is stored in database objects which are called tables. As I said earlier when I said Microsoft Access is an relational database management system, it's that it stores all the information in tables, and those tables are called relations. That's why it's called a relational database system. Now, this table is basically a collection of related data entries and consists of numerous columns and rows. Remember, a table is the most common and simplest form of data storage in a relational database. Now, the following program is an example of a customer's table. Now, what is a field? Every table is broken up into smaller entries called fields. The fields in customers table consist of ID, name, age, address, and salary. A field in a column in a table that is designed to maintain specific information about every record in a table. Now, a record is also called as a row of data and each individual entry that exists in a table. For example, there are 7 records in the above customers table. Following is a single row of data in the record of the customers table. So you've got now ID 1, Ramesh, 32, Ahmed Dabad, and the 2000 for the salary. That's one single record. Then a record is a horizontal entry in a table. Yeah. Then a column. A column is a vertical entity in a table that contains all information associated with a particular field in a table. For example, a column in the customers table is address, which represents location, description, and would be as shown below. So address, you can see all the addresses of all those records, yes. Then null value. A null value in a table is a value in a field that appears to be blank, which means a field with a null value is a field with no value. However, it is very important that you understand that null is not 0. Yeah, a null value is not equal to a 0 value or a field that contains spaces. Yeah, because space is a character, which, consider this, an empty set. An empty set is a set that has nothing, but an empty set is not a null set. Yeah. Null value is different from a zero value or a field that contains spaces. A field with a null value is the one that has been left blank during a record creation. A null value means that that field has no particular property. It wasn't left blank. It's not something that's missing. It just doesn't. The value there is null. Then 0 is also a very different value. For example, if I ask you how many cars do you have and you say 0, that's a value. It's not a null value. It's a value on itself. Yes. Then SQL constraints. Now, constraints are the rules enforced on data columns on a table. They are used to limit the type of data that can go into a table. This ensures accuracy and readability of the data in the database. Yeah. Constraints can either be on the column level or table level. Now, column level constraints are applied to only one column, whereas table level constraints are applied to the entire table. Now, for example, when I was creating all those tables in Access, and then I changed the date format to medium date. Now, that one makes it, that's an SQL constraint. Yes, it has to be in a specific format. When I change the field value to a specific number, that's a column constraint. Yes, that's a column constraint. Now, following are some of the most commonly used constraints available in SQL. The not null constraint ensures that a column cannot have a null value, which means you cannot leave it empty. Yeah. Then a default constraint provides a default value for a column when none is specified. For example, if a default constraints provide a default value for a column when none is specified. For example, if if I'm going to ask to select, let me just even use access. And I can use the marbles DB. Yeah, in marital status here in design view, I can change the default value to S, which stands for single S. Then view, I should view. Right. No, this is not. Okay, this is where I wanted to, and the default value here being. I can just say S because it's text, yes. And then save its datasheet view. So if I come here and say that number 23, please David on 23rd, 1287. You know, these are constraints that I actually put to have those dates that way. Then and like 40,000. The default here is S. Until I choose otherwise, the default will be S. Even if I come here to the SQL statement, I told you there is, okay, here in SQL, okay, this one doesn't have SQL as per that. You're going to say that is defined. Then a unique constraint, it ensures that all the values in that column are different. Yes, for example, this home table fields, you have a default value right here, name and caption. Then just click here, unique. It ensures that none of that data is repeated. Like you cannot have another 10 here. A duplicate value in the index, primary key or relationship. Change the data in that field that contains duplicate data. That is, remove the index or redefine the index to permit duplicate entries and try again. Yes. Yeah, you can also make it a requirement. Now, a requirement is when you cannot leave it null. You cannot leave it null. Inamaanisha huwezi acha tu ikiwa empty, and null values are not accepted. Yes. Then primary uniquely identifies each row or record in a database table. Then foreign key uniquely identifies a row or column in any other database table. For example, your ID number is in your personal details table. You've got your name, ID number, and probably your date of birth. Now, all the other tables are going to uniquely uniquely identify you using your ID number, and that one becomes the foreign key in each of those tables. Then check constraints. It ensures that all values in a column satisfy certain conditions, and then index. It's used to create and retrieve data from a database very quickly. Then you've got data integrity. The following are the categories of data integrity. You've got entity integrities, that there are no duplicate rows in a table. Domain integrity enforces valid entries for a given column by restricting the type format and the range of values. For example, in the marital status column, I cannot write any other. Let's see whether I try to. Okay, I want this field to be required. Now, if I start writing a Y, not even Y, if I write here 500 and then $sign, it's going to give me a real issue here, because a $sign is not a value. So right now the 500 will be okay. If I come here and write R, the text you entered isn't an item in the list. So you can edit the items in the list, or you can enter an acceptable one. Immediately it's supposed to in access. Then referential integrity, that is, rows cannot be deleted, which are used in other records. For example, I have queries based on a table. I cannot delete that. I cannot delete that row or column in that table. Then user-defined integrity, that is, it enforces some specific business rules that they do not fall into entity domain or referential integrity. This is whereby you can specify your own rules. Then database normalization. Now, database normalization is a process of efficiently organizing data in a database. Now, there are two reasons for this normalization process. One, eliminating redundant data, for example, storing the same data in more than one table. Then two, ensuring data dependencies makes sense. Then three, both these reasons are worthy goals to reduce the amount of space in a database and consumes and ensures that data is logically stored. Now, normalization consists of a series of guidelines that help guide you in creating a good database structure. The normalization guidelines are divided into normal forms. Think of a form as a format or the way the database structure is laid out. The aim for the normal forms is to organize the database in the database structure so that it complies with the roles of the first normal form, the second normal form, and finally the third normal form. It's your choice to take it further and to go forth with the normal form. Now, the fifth normal form and so on, but in general, the third normal form is more than enough. Now, I'm not going to go into details on normalization. However, I'm going to give you an illustration on normalization. And I'm going to use, let's say, PowerPoint. Now I'm going to use this for, now you've got original. Now if you have a student, let me just say table, number of columns, number of rows. Let me just use 5. Okay. And I have, yeah, let me write this as a student table. Now a student has various attributes. You can have your admission number, then you can have your ID number. This is national ID number. Then you've got your name, and after your name you've got probably your DOP, then age, okay, let me not write age. I'm going to add several columns there to the right. Admission number, then you've got the unit you're taking, you've got the lecturer teaching you that unit, you have the unit code, you've got the course you're taking, you've got, all these are your details, the course you're taking, you've got year and semester right there. And you've got even your department. But since your school has only one database, and you can just say your name is, your admission number is, for example, CT201, yes, your ID number is, okay, let me just write 1, 2, 3, one that I can more, 1, 2, 3, 4, 5, 6, 7. Then your name is Z, your DOP, let's just say it's 1990. Unit you're taking is DB. The lecturer teaching you is Anne. The unit code is IT40. The course you're taking is information, let's just say IT. The year is 2022. The semester is, okay, now the year, you are in year 2, and the semester is, this is the first semester, and the department is computing. Then you've got another admission number here, food science 345, yes, ID number, and it's 7 digits, so name is Henry, date of birth is 23rd of November 2000, unit taking me organic chemistry, KOC. The lecturer there is massive. Unit code is FS is FD for department 23. Then the course they're taking, of course, food science. They're in year 2, semester 1. And the department is food science. You can just write food. So, and then you have to then you have the lecturers. The lecturer. Yes. The lecturer's table. You know, every lecturer also has an ID number. On top of that ID number, they have the staff ID, the unit they teach. That unit still has a unit code. That unit still has a unit code. And you have to clarify anafunza in which year and semester. I'm not sure that I'm spelling the word semester correct. Yeah, semester. And that lecturer has a department. And that department has yeah, you've got department. What else do I need about that lecturer? Oh yeah, I forgot the name. So let me delete this. So insert left. Let's start with the name. Yes, we've got an ID number, staff ID, unit inafunza ni DB. The unit code is IT40. The guy is to semester 1 and the department is still computing. Then, okay, we've got Mercy's record, Mercy admission number. The unit they're teaching right now is organic chemistry. FD23. Year 2, semester 1. And this is fourth. Yeah. You notice this is a very different table with a very different record. Then you get Yeah, and let's leave it like that. So with these two tables, you're going to realize that there is a lot of information that has been repeated. So if I just come here, and the first normalization form is to make sure that there are no repeated entries. And since there are none, we just have two entries. That one is okay. Then, of course, we can switch it up. Now, then anything that's not directly related to this, you put it in a separate table. So for example, here, and note this is before you even start coding. This is how you plan your database. This is how you plan your database. Yes. Okay, you can just write 5. Now, the first one is unit. Let's start with the unit code. Yes. The unit code, then the unit itself, that is the unit name. Of course, the unit is offered in a particular year, in a particular semester, and is taught by a particular lecturer. So here, IT 40, the unit being DB, is taught in the second year, semester 1, and the lecturer is always an. Enter. Okay, let me insert below. Then here, FD23, and it's called organic chemistry, taught in the second year. The first semester is taught by Mercy. Now, with that, I can now comfortably change this. Let me just copy the entire table. Derived table, units. Yes, then insert on a slide. Then you get truncated table. Now normalized tables. Okay, let me just, yes, that one ends. This one. Now, the units. No, I'll just need one thing. I'll just need the unit. I don't need the lecturer because I'll know that if the unit is debate, otherwise you're having repetition. If the unit is debate, definitely it's being taught by Anne. The unit code is IT40. Now the course is not equivalent, but it's year one and semester one. So this one, all this information will be deleted. I'm trying table design. Even this one, because I'm very sure. Then the next table to be the normalized tables. Even this one will be normalized. Let me see whether I can break this section down. The layout. Normalized tables. Let me change my view from this point. On to content. Not comparison, but to content. I'm hoping as I do this, you're also learning a few tricks. Okay, let me. So I want the lecturers table right here. Yeah. So, and with that, I can just leave the unit and the unit code the year and the semester. Now, everything I've left here is directly related to the student, the department, to the actual student. That's how you normalize forms. And I've just extracted a new derived table unit. Yes. And the next thing the next thing you're going to avoid is repetition. So then avoiding repeated data in multiple tables. And as you can see, okay, now after you've normalized, now you have another table called, okay, unit ought to have course, so insert, notable layout, insert right, you need to have the courses. And you can have your multiple courses, for example, IT, CS, IS, yeah. And in food science, you have got food science, you've got food technology, you get catering. I'm just going to write it as C. Yeah. Then the next thing you'll need, so that you don't repeat course everywhere, is a new table. Let me just change this to title layout only. Then the title layouts. So the new course and department, the new course table. And this one is going to be, okay, I can just write 5. I'll need to insert below. This one is going to be a lot. So you just have to write course and department. So IT, computing, CS, computing, the other one IS, computing, there was city somewhere. Okay, you can write city, computing, and okay, food science, food, food technology, food, then insert below catering food. In case there is any that I've left out, don't worry about it. Yeah, so delete columns. Yes. Now with that, I can now have the, okay, let's just say normalized tables. Now let me just change layout to title only. After that, and including even this one. Yes. So now the department, okay, you can leave the department there, but here when you have the course and department, this one definitely now goes. Yes, that one goes. This one has no course and department, so you just leave the department. This one has course. Yep, and that one you can leave it. Yes. So by the end of the day, the database will have 4 columns. We'll have 4 tables. Okay, wait. Admission number unit. Yeah, and with one admission number, this admission number to 1, I can tell the ID number is this, their name is this, their due is that, the unit they're taking, and the course they're taking. Now, with the unit name, I can just come in unit name and check the unit code, can check the year and the semester of that student and the lecturer, and the course is repeated right there. But the course is a one-to-many relationship. In the lecturer's name, lecturer, yes. If you want to find out more about the lecturer, I'll simply come here and say an ID number that unit this. In fact, I think I can delete the unit here. It should be deleted. It's a repetition. Yeah, if I just have the lecturer, I'll definitely know that that lecturer right now is teaching DP. So I'll just come here to the lecturer and find out all about them. Yes. So by the end of the day, you have tables that look like in the table department table. You'll have 4 tables, but you don't repeat any information, because with just some basic information you can get the other information. So instead of having every record repeat, instead of you having to repeat and every single time you repeat DP, you simply write DB once and AN once. Yes. And that's how you normalize your data. Then the next thing, Yeah, that's how you normalize your data. And by the redundancy means where you repeat data that has been already entered in different ways in different tables every single time. Then this Oracle features, access features, SQL syntax. I'm going to cover syntax tomorrow. Let me cover syntax tomorrow, whereby you'll have installed the XAMPP code. Yeah, let me cover syntax tomorrow. Now, have a lovely day. My name is Esther. I'm from Dinaco Enterprise. Where we do data analysis. And consulting. Yeah.